in this question, this is a uniform semicircular wire and we need to find out the force acting on this small mass m due to this uniform semicircular wire of mass m and length L. Let us now find out first the radius of the wire. Pi r is equal to L. Therefore, radius is equal to L upon pi. We will use this if needed in the future. Now we need to find out the force on M due to this uniform semicircular wire. So what we do is that we add up the forces acting on this small mass M due to each of the small elements of this semicircular wire, and then we add them vectorially. So now let us analyze one thing. At an angle theta, suppose there is an element. Due to this particle, a force acts on this small mass M in this direction. At an equal angle theta, from here, there is another element which exerts a force on this small mass M in this direction. These two forces being symmetrically, by symmetry we can say that the resultant lies vertically upwards. Now similarly, for each of the pair of small particles, the resultant will come in the vertical direction. So the final resultant force acting on the small mass M due to the uniform semicircular wire comes in the vertically upward direction. So what we need to do now is that if we can integrate the y component of the forces, if we take the y component of this and the y component of this, we will get the final resultant vector due to each of the pairs, and if we add up each of the y components, we will get the final resultant force acting on the small mass M due to the uniform semicircular wire which is in the upward direction. So now we do that integration. As we do it always, in this case whenever we have to assume a small element, we take a small element subtending an angle d theta at an angle theta. The location of this element is at angle theta and it is subtending an angle of d theta. The small mass dm of this element is equal to mass per unit length, that is m upon L, into r d theta, that is the length of this object. Mass per unit length into the length of this object gives us the mass of this element, that is equal to mr upon L into d theta. The force exerted by this element on this small mass m is equal to gm dm upon r square, but it is in the direction oriented towards the particle. So we have to take the y component of this. This is the x component, this is the y component. The y component will be equal to the parent vector into sine theta. So this is the y component of the force acting on this small mass m due to this particle. Now we integrate this force for all such particles ranging from 0 to pi to find out the total resultant force acting on this small mass m. We replace this small mass m dm by the above formula. You get gm upon r square into m upon L r d theta sine theta. This is equal to gm m upon rl integration 0 to pi sine theta d theta, which is equal to 2gm m upon rl. Now r is equal to L upon pi, so this becomes 2 pi g mm upon L square. So the final force acting on small mass m due to the uniform semicircular wire becomes equal to 2 pi g mm upon L square in the upward direction.